Kate, you've done the classic. You're on mute.
God, you think I'd learn from a day job? So yeah, just with in lines with GDPR and all the personal data aspect. If anyone doesn't want to be recorded, if you could go off camera, that'd be great. Failing that, we will be, like Richard said, just recording the session because there's a few people that couldn't make it today. So I'll kick off with some of the questions. Just to, I suppose, consolidate them. So, some of them, Richard, you have already answered, I think, in some of the group chats on Facebook, but again, I just want to kind of bring it into one space. So I think one of the big questions that keeps coming up a lot is, especially because I think the UK is quite behind with regards to heat pump installations and everyone being trained up in them and the education and awareness around them. So I think there's a lot of uncertainty around how do we go about finding a reputable, trustworthy company. So I think that's come in from Kim online. So what's the easiest way? And I think you might have sent a link out. So would that cover us being able to search, and then, you know, is there any kind of minimum standard they need to achieve?
Yeah. Okay. So for a start, if you're looking to get some independent advice on the viability of heat pumps for your homes, and with the note that all homes are suitable for a heat pump, the first thing that you must do is ensure that your installer or anyone you speak to is MCS registered. MCS is your guarantee that the people who you're speaking to have been vetted by MCS and meet the standards required to design a heat pump system and then subsequently to install it. There are people who install heat pumps who aren't MCS registered, and if you do that, then you have virtually no consumer protections other than the manufacturer warranties directly. With MCS, you've got the certification bodies that they belong to, and then finally you have MCS who can also act as your last point of resort if you have issues with your installer. But you must use an MCS installer. For what it's worth, I know that there are issues around how you might feel about British Gas. British Gas are an MCS registered heat pump installer. I mentioned this at the previous meeting. British Gas, despite their name, are moving into heat pumps in quite a big way. And if you were to go down the heat pump option through the scheme, it is most likely it would be British Gas who would install it, and British Gas are MCS certified. So they've gone through the training, they've got the necessary requirements to install them. If you want independent advice, which again, I would, in most major purchases in life, we don't just take one word. I've just dropped a link in the chat to the Find a Contractor link on the MCS website. Through that, you can do a search. Very simply, put in your postcode, put in what you're looking for, and it will give you a number of local installers to contact. And it's certainly worth. I know a few of you have already done that, but please do not speak to somebody you know who knows somebody who can bung you a heat pump. Don't do that. MCS is your fallback, that they've passed the necessary qualifications and have been assessed as being suitable and capable and competent to install a heat pump.
So would you say, Richard, that that's kind of the equivalent of a Corgi registered gas fitter? They have to meet a minimum standard.
We don't particularly, MCS don't usually like the comparison, but it's like the Trustmark or the Gas Safe, if you like, for heat pumps.
Okay.
Gas, I would add to that, the Gas Safe is not as strenuous as MCS, but yes, so it's MCS is the Gas Safe or the Trustmark, if you like, of heat pump installers. So it's your quality mark.
Brilliant, thank you. And I'll share the link as well on the Facebook page again when we send out the recordings. That's really useful. So there's another question from Graham who's on the call at the moment. So what are the issues with a heat pump for a 1920s semi that's got solid walls? So I suppose in theory, is it suitable for a heat pump? What can they do? Pros and cons, etc.
This is the classic question that it's I have two ways of answering it. One is the generic, all property types are suitable for a heat pump. in the same way that all properties can have a gas boiler. The issue is not so much that the how it's a question of the efficiency. The more thermally efficient you can get your house, the better insulated, the more efficient the heat pump will run. And that's true whether it's a gas boiler or a heat pump, a wood burner, or, you know, an open fire. It doesn't matter what the system, it doesn't matter what the source of heat is. It'll be more efficient if your house is more efficient. So without seeing the specifics of the house, other than to say more insulation, fabric first approaches are always what we're going to suggest that you need to look at. How can you make the house more thermally efficient? I appreciate with solid walls, there are some limits to what you can do. I mean, there is the option of external wall insulation if it's detached. You can get internal insulation, which is quite thin, which will improve the thermal efficiency of the property. But the key thing, and the only way to fully answer that question, which is the benefit of a heat pump, is to have a proper home assessment done by a qualified installer who knows what they're talking about. Because there are some generic points that I can make. You know, you could have external wall insulation, you might be able to get some internal wall insulation, but the specifics will come down to the specifics of your house. And that's where you need to get someone in from an MCS registered installer in to look at your property. A heat pump will heat your home, no problems whatsoever. You know, that's not the issue. It's a question of you want it to heat it as efficiently as possible to keep your running costs as low as possible. And the best way to get that answered is by having someone come and look at your house. So I'm kind of answering it by not answering it. You know, there's some specific points. You know, external wall insulation, if possible, that comes at a cost. Internal wall insulation, that comes with some disruption because you've got to take everything off your walls. But the best way to find out the specifics is to get someone to come and look at your house. With the point to be made, a heat pump is perfectly capable of heating anybody's house on the planet. You can get high temperature ones, even low temperature ones. You know, they will be able to warm your house, but you want to do it as efficiently as possible, and that's true no matter what heating system that you're using.
Thank you. The reason I asked is that there's a lot of people are saying, you know, Cadent rather, are saying, oh, most of the houses around here aren't suitable for heat pumps, which obviously we know it's a lie. But,
No, but it's a good call out, Graham, because I think that's one of the big issues that we've had with a lot of questions of saying, I don't have cavity walls, therefore I've got solid walls. It's a little Victorian house. It's quite cold anyway. It's not going to be suitable for a heat pump. So I think it would be good just to kind of do a bit of myth busting as we're going along. So on the back of that Graham and Richard actually. So I think something else that we've been repeatedly told, rightly or wrongly, is I'll just go twofold. So one is it won't work at certain low temperatures, and then we've been obviously, you know, we've seen stories and links of people either having exorbitant you know, heating costs from the heat pump, or that it just doesn't work because it's too cold. And then secondly that you can't have it without underfloor heating, which was a bit of a new one for me. So it'd be good just to get your thoughts on that.
Okay. There's a lot in there. I'll go to the first point about you being told that your properties aren't suitable for heat pumps. And Kate and I have spoken about this a few times. Cadent are running a trial to try and promote hydrogen boilers. So let's just leave that there for a second as to their approach to heat pumps. But further to that, my understanding is most of the people doing the in-home assessments are in fact from British Gas. And I'm guessing that they are gas engineers, not heat pump engineers. So they will be coming in with their understanding and what they might have been told from someone further up in their organization. So with the best will in the world, they might be telling you what they think is accurate, but it's not, because they don't know enough about heat pumps. So that's a slight caveat on that point. With regards to low temperatures, again, the same is true of any heating system. The colder it gets, any heating system has to work harder to keep your house to temperature, because there's a bigger difference. If it's -5 and you want your house to be 20, there's a 25-degree balance that's trying to figure out between outside and inside. and then it gets into the thermal efficiency of your home.
Mhm.
Whenever it was 2 weeks ago, when it was absolutely freezing outside, my house, which has an Mitsubishi EcoDan 8.5 kilowatt, other heat pump brands are available, my house was warm. You know, my house was warm. They are perfectly capable of functioning. They, you know, the most common form, no, let's take that back. 1 in 3 households in Finland, where it gets rather cold, have heat pumps. Heat pumps work. You know, it's not a new technology. It's to suggest that they don't work at low temperatures is, you know, is just simply not accurate. It's not accurate. It's an easy line, but it's not true. Yes, they have to work harder, but then any heating system has to work harder as it gets colder. When it comes down to running costs, this gets back to, there's a whole range of factors involved in this one. And again, you're probably going to get sick of hearing me say it, but it's true of any heating system. It's not just true of a heat pump. If it's not installed properly, if you have poor insulation, it's going to cost you more to run. And that's true of any heating system. A well-insulated house with a well-installed heat pump. In fact, there's just some analysis out today by the Heat Pump Association, who's one of the trade bodies who promote heat pumps, which I can send a link to. They've just done some analysis on running costs, and with the current prices of gas, a well-installed heat pump is less expensive to run than a gas boiler. And it's also important to note that under any scenario imaginable, a heat pump will always be less expensive than a hydrogen boiler, should it ever come to that. But again, your running costs, and the more expensive thing, it also depends. Like a heat pump is designed to be on essentially all the time, just ticking over in the background. It'll get your property up to a certain temperature and keep it there. If you've got a nice thermally efficient home that keeps the heat in, the heat pump will just tick over quite nicely. If you use a heat pump in the same way that you use a gas boiler, you know, you try and ramp up the heating and then turn it off for the day, it'll be more expensive because that's not how it's designed to be used. If you run it all day and then set it back at night 10 degrees, it'll take ages to get back up and it will cost you more money. So the key thing with a heat pump is that you use it differently to a gas boiler. It's meant to be on more or less all the time and set back a couple of degrees at night if you want, because the heat pump will just modulate the temperature quite nicely all the time because that's what it's designed to do. So if it's designed properly, and again, bearing in mind, when you get a heat pump installation done, there are 2 elements to it. There's the design of the system and there's the installation of the system. To get a heat pump system designed, every home, no matter how similar they look from the outside, every home has an individual survey done to do a heat loss calculation of that property, to take into consideration all the quirks there may be of that property. So each home has its own heat loss calculation done, its own room by room design, and a system designed for that house. So a properly designed, well-installed heat pump running at a high efficiency is going to be at par or better than a gas boiler. And as I said, it will always be less expensive than any version of hydrogen ever. The underfloor heating one that came up is in that helping you make an informed choice, bro. I mean, that's just simply not true. I live in a 1950s post-war semi. I have a heat pump. I do not have underfloor heating. You do not need underfloor heating. In a new build, if you're building a new build house and you want a heat pump, absolutely. Underfloor heating is the best option because you can run the heat pump at a really low temperature. I replaced some of my radiators, which I'm sure is one of the other questions that's probably going to come up. My radiators aren't bigger, they're wider because some of them have gone from being single fin to double finned, but you do not need underfloor heating for a heat pump. It will run quite happily through your existing radiators. And as I said before, my house is toasty warm and you do not have, I've got tiled flooring and wooden floorboards throughout downstairs, and there's no way I was ripping all that up to put my heat pump in, much as I'm keen on heat pumps. You do not need underfloor heating. I can categorically state that. If you're buying a new build or sticking a 50-foot extension on the back of your house, go for it. But otherwise, you do not need underfloor heating.
Perfect. Thanks, Richard. I think that nice to have a clear answer to questions. Quite refreshing. Quite refreshing. So next one, we've got going back to the MCS certified and registered. So the questions come through. Is it the company that's MCS certified, registered, or will it be each individual fitter? Is there a difference?
It's the company has the certification, and the contractors have to prove that they're competent to be with that company.
Okay.
So yeah, so it will be, and I mean, again, depending on who you end up getting to install if you go down the heat pump route and an independent, I mean, lots of these companies are small companies and there may only be 1 or 2 people. But it's the company has the registration, but they obviously have to install to MCS standards. Therefore, their installers have to be MCS is also it's slightly changing its structure, and it's gearing more, which it hasn't done yet, but it is in the process of going more towards a competent person scheme, so focusing much more on the individual. But it's the company that has the certification, and it's the company that is responsible for the standards. So if you're an MCS installer, an MCS company rather, you are going to make sure the people who are doing your installations are up to standard. And they will obviously have been trained. They'll have gone on heat pump courses. The design, if you're doing the design element, you will have done the design courses. If you're an installer, you'll have done the heat pump installation courses. So it is very much geared around ensuring that at every stage of the process, the people who are coming into your home are competent to do what they're doing.
Perfect. Thank you. Does that answer your question? It just says Humph as guest. So Humphreys, maybe? I'll take silence if I don't hear anything as yes. So in which case I will move. Okay, perfect. I'll move to the next one. So Stephen Lith, feel free to come off speaker if you want and talk through, just so you don't have to hear my dulcet tones constantly.
I'm happy to talk anyway. Okay, it's not a problem.
It's getting you back off on mute, isn't it, afterwards?
Yeah, shut me up, yeah. I mean, really, it's obviously electricity itself is far more costly than gas anyway.
Mm-hmm.
So it's a case of marrying up the electricity, obviously, with the heat pump. And I'm wondering how we do that as efficiently as possible when you've got to run, obviously, the heat pump all the time. I mean, would you do that with solar panels and a battery, married up to a heat pump?
Okay. Well, so again, there's quite a few different elements in that question. When I say that you run the heat pump all the time, the heat pump isn't physically running all the time. It will, mine, for example, will run for a certain period of time. The house gets up to temperature and it will just sit there, and then it will come back on just to, put warm water through the radiators again to make sure it stays. So it's not actually running 24/7. It's on 24/7 in terms of maintaining. So just to clarify that point, it's not going to be, running the entire time. The question then comes down to take a step back about the costs. As I said earlier, there's a lot of research now coming out that shows with current gas prices, a well-installed, efficiently operating heat pump is less expensive than a gas boiler now. One of the things that the government is looking at doing, which we are very, very supportive of, is changing the way that electricity is priced. Because without getting too technical, one of the anomalies of our electricity system, our pricing system, is that gas is what most often sets the price of electricity, rather than renewables, which quite often contribute an awful lot to the grid and are way less expensive. So government is currently looking at reforming how electricity is priced, and there's a number of things they're looking at doing, one of which is introducing half-hourly pricing. So everyone will go onto dynamic pricing. So for example, when the grid is being fed 80% renewables, which are cheap, electricity will be much less expensive. On those rare occasions when gas is providing most of it, then it's going to be more expensive. But the point being is you're your electricity price, even during the course of a day, could fluctuate. But if they it's called decoupling. If you decouple the electricity price from gas and reflect the actual balance of where the electricity is coming from in the grid at any one time, it will become cheaper. Because at the moment it's artificially set at whatever the highest supply was. I can't remember the exact time frame now, but it's generally electricity is pegged to the price of gas, which makes it artificially high. You separate that and electricity will become a lot less expensive, which means the economics of heat pumps become even better because your electricity is going to be cheaper. Therefore, your heat pump running costs will become cheaper. There are electricity suppliers out there now who are offering dynamic pricing. Such as Octopus is probably the one that leaps to mind. Octopus have got a number of tariffs that are in beta mode, so they're still like a user testing mode, and they are offering dynamic pricing now. They offer a heat pump tariff where they offer 3-hour blocks of time during the day where it's a lot less expensive, one of which is 4 till 7 in the morning, which is perfect because your heat pump runs nice, has 3 hours to get the house up to temperature at about 22 pence a kilowatt, which is a lot less expensive. And then again, I think later in the evening. So dynamic pricing will make heat pumps less expensive to run. Decoupling, well, to simplify it, electricity market reform will make electricity cheaper. And that's coming. It might be a ways away, it might be a year, 18 months away, but it's coming. And bear in mind that based on figures now, a heat pump, a well-installed, efficiently running heat pump is already less expensive than a gas boiler. And again, just to reiterate, will always be less expensive than hydrogen should you ever end up having to pay for it. So hopefully that's answered your question.
Yeah, it has. Yeah, as soon as you said it was less expensive than an existing gas boiler, then that's away, you know, away we go. It's the cost of obviously installing everything, you know, with regards to the solar panels, the battery, and the heat pump.
Yes.
That's where the real cost is.
Yeah.
Well, yeah, and I'm glad you because I missed that point in my overcomplicated explanation of electricity markets. I have solar panels as well, and there is some research that I can send you links to around the value of solar in running heat pumps, and this is where it does get into a case of, you know, how much budget do you have to do all this stuff. Solar panels, obviously, their real benefit is going to be in the summer when I'm not drawing anything from the grid at all, and my hot water through the heat pump is free of charge. But what I'm saving through the summer is offsetting my winter costs. And today I live in Norfolk, and today was a lovely sunny day in Norfolk, and I have the benefit of having a roof that faces southwest. So when there was sun today, my heat pump was running off my solar panels for about 4 hours. And then if you want to go the whole hog and get battery storage as well, then sure, you can either charge your batteries through the solar or through a time of use tariff at night when it's less expensive, and it will then run the heat pump during the day. But that again is where you need to have someone come in. If you want to go the full package, then you need to get someone to come in and do some analysis of your energy use to find out, is it actually cost effective to do all that or not? So for example, I did the heat pump and the solar panels, and I stopped at the battery because I don't use that much electricity, and actually wasn't worth me spending the extra money for batteries because I simply wouldn't get the investment back. And as it happens, MCS also certify solar panels and batteries. So get someone in who knows what they're talking about to look at your energy use to see if it's viable to do that, because that would be a considerable investment to do all three. And by all means, you know, there's other reasons other than money to do it. But that's where it becomes a more complicated calculation on how much energy you actually use. Is it worth the payback? And then you get into some of the more complicated points around your PV is going to last 20 to 25 years. Your batteries are going to last 10 to 15. So at some point during your PV's lifespan, you would have to change your batteries. And that's a whole rate, you know, that's where it does start to become slightly complicated. But the simple point around the heat pump running costs based on electricity, it's less expensive. A well-installed, efficiently running heat pump now is less expensive And when the government sorts out electricity pricing to make that less expensive, your heat pump economics become even better.
Perfect. Is that good for you, Stephen? Yeah.
Yeah, thanks very much, Richard. Appreciate it.
All right.
Well, thank you. I'll come back to Hump's second question in a second, because I'm just going to go through. I'll join up two questions because Marge and Karen were a bit late. They were struggling to log in, but they've raised two questions that were similar to one of the earlier ones. So hopefully we can just kind of answer that straight away, which is one, are we going to need to have huge radiators, as this is something we've heard? And then secondly, we've been told our cavities are too small for insulation, and will that mean our house is not suitable for a heat pump? So that's Karen's and Marge's. Karen, Marge, we have answered this earlier on in the call, but hopefully Richard can just respond again to put your
Sure.
mind at ease.
Okay, first off on the radiators, and again, this gets back to the point I made a few times now. Without the benefit of an MCS registered installer doing your heat pump is they will come into your house and tell you exactly what you need in your house. It may be that some of your radiators need to be changed, but to use my example, my old system boiler was ancient, and there was goodness knows how much crud. And I was told you can keep a couple of those, a couple of them you should probably resize. And I changed them all because I didn't really want to have my nice new heat pump system having a 30 years worth of crud, even though they were going to power flush it. I went from a couple of single finned radiators to double finned, so that effectively doubles the
Width.
surface area and doubles the width. So they're wider, but they're no bigger. Now, in some situations, depending on the size of the room, you may need to get bigger radiators, which are longer wider rather than deeper. But not always, and in some instances, you won't have to change your radiators at all. And that is the importance of an MCS registered installer coming to your home to tell you exactly what you need in your home. So without seeing your house or the size, I mean, it may be that when you had your original heating system installed, you had undersized radiators put in then. I mean, who knows? So the answer is not necessarily, but maybe. And then the second question was cavity walls that are too small for insulation.
Yeah, so cavities are too small for the insulation, so it will mean the house is not suitable for a heat pump.
Okay, well, I'd be curious as to who said that the cavities are too narrow for insulation. That would be point one, but fair enough. And point two, there's ways around that. I mean, again, as I said, I think it was Graham's question earlier, an MCS installer, certified installer, will come and look at your home and say what you need. There's the options for things like external wall insulation, which I grant you is an expensive option, but very, very effective. You can line your walls internally with insulation, which would obviously have some disruption and decoration issues. But without seeing the property and having someone come and do an actual specific survey of your home, it's difficult to answer that. But the point being that I made again at the start as well, even allowing for that, a heat pump will still heat your home. It may not work as efficiently as it could do if the home was better insulated, but it will still heat your home. Saying your home isn't suitable for a heat pump because of X, Y, or Z is not true. It's simply not true.
Perfect. And
Terry.
I think
Oops, sorry.
Oh no, no, I was just going to say to reiterate to Karen and Marge, we said earlier on at the beginning of the call, there's a link that we'll share where you can find MCS registered installers, because we've all got these slightly nuanced houses, cavity walls, insulation, and we'll get to yours about your suspended floors. But I suppose ultimately, as Richard said right at the beginning of the call, all houses will be suitable for a heat pump. It'll just have various different running for efficiency. But the only way that you'll be able to actually find that out is to get someone to come and do your heat loss survey, where they come and specifically create this bespoke plan for yourselves. And then, sorry, did Terry have his hand up as well?
He did. He does.
Terry, do you want to come off mute if you can? If not, feel free to type your question in.
That's all right. Sorry, I found it. My mouse stopped. I spoke to a gentleman on the phone today from an installer, and he was talking about a COP value of 4. Is that being a bit ambitious?
Sorry, what was that, Terry? He spoke about what? Sorry.
COP value, the energy in, energy out.
Yeah, so
And everything I've read has said 3 times, you know, 1 in 3 out. I'm just wondering if 1 in 4 out is a little bit ambitious for a heat pump, or
okay, well, just to explain, coefficient of performance is a measure of how efficient your heat pump runs effectively. As an example, a gas boiler would run at about 0.85%, 0.85. So for every 1 unit of energy you put into it, you get about 85 out, 0.85 out, if you're lucky. Direct electric, so straight electric radiators, it's notionally 1-to-1, but not quite. And the beauty of a heat pump is that for every 1 unit of energy you put into it, you should be getting 2.7, 2.8, 3 to 4 out as well. 3 should be something that would be, again, a well-installed, well-designed system should be getting 3 without too many problems.
Yeah.
4, it would depend on your property, Terry. I mean, you're probably going to hear from
appreciate that.
Sick of me saying that, but it would depend on the thermal properties of your home as to whether that was possible. Theoretically, yes, it's possible. I mean, ground source heat pumps can achieve that without any problems at all. An air source heat pump getting 4 would be doing very, very well.
Yeah.
But I'm not going to say it's not possible. And that could take into a whole range of other factors. Yeah, it's certainly possible. It will be very, very top-end installation that will be working incredibly efficiently. The high 2s, low 3s is certainly a lot more achievable, and I'm going to avoid the word. A well-designed system in a well-insulated house should have no problem hitting 3 or above.
Yeah.
But it also depends again how you use it and all those other variables that I've mentioned a few times. So I would suggest it's optimistic, but not impossible.
Okay, thank you.
Perfect. Thanks, Terry. I'll go to Graham's question, which is, what are the issues with microbore pipe, and does it make a difference? And for the purpose of myself and many others, maybe, what's a microbore pipe?
Microbore is essentially small pipes.
Okay.
So I think it's about 10 to 12 millimeters is the pipe, is the size of the pipe. Microbore is a bit of a contentious one, because if Julian was here, Julian Hodgson, my MCS colleague, who unfortunately isn't here because he's got COVID, Julian would suggest that is a bit of an issue. But if Bean Beanland was here, not only does Bean have the best name in the world, he's probably the most knowledgeable person on heat pumps ever. He would say microbore is not an issue. This is where my technical expertise around heat pump design is being tested, but principally, and I can get you more precise information, but the principal issue is around the flow rate. How much water can you push through the system at that temperature to achieve the desired temperature? So my understanding, the principal issue with microbore is, can you achieve the necessary flow rate to make the heat pump work efficiently? And again, as I said, some people would say, oh, that is an issue, and others would say, no, it's not. And to repeat my mantra, it gets back down to the design. And there are certainly lots of heat pumps out there in houses with microbore that don't have a problem. And there's no problem for it being MCS certified in microbore. Microbore in and of itself is not a reason not to have a heat pump. There are some installers who are more comfortable installing with microbore and others who are less comfortable. But in and of itself, it's not an issue. And my understanding is that the principal technical problem is, can you achieve the necessary flow rate to get the heat pump working as efficiently as possible? And obviously, because it's a small pipe, it's more difficult because it's a small pipe. You can't squeeze as much through as rapidly as you need. But if you want further precise clarification, I'm happy to get Julian to write a detailed explanation and I can send it to Kate.
I think that would be helpful, thanks. It's just that I've got 2 radiators on Microbo
Okay.
off a normal system.
Yeah, I'll ask Julian and Bean to write if they can, like a 2 paragraphs each, so you can see.
Yeah.
But in and
Yeah.
of itself, it's not an issue. But some installers will be more wary of it than others, which is not to say that some installers are better, or it's simply the case that some are more comfortable dealing with it than others. But it's if you want to really geek out and go into some heat pump forums and type microbore in, you'll see that it generates some debate. But there are lots of heat pump systems out there operating quite happily with microbore.
Fab. Thanks, Richard. I'll add that one then for us to take offline, so I can
Yeah.
follow that up, and then I'll publish the answer afterwards. So I'll move on to Anne. So Richard, do you have suspended timber floors? If so, have you had underfloor insulation fitted? And I suppose if the answer is no,
No.
comes back around to if you have suspended floors, which I think a lot of us do. Again, it's that whole insulation. Do we have to insulate, or, you know?
No, I don't, is the simple answer. And no, you don't. I mean, again, yes, you can, but no, you don't have to. Does
it come back to what we were saying before, that for any heating system, you know, to insulate everything is ideal, but you know, there's obviously limitations to everyone, because at the moment, you know, I've got a gas boiler. I've already found out through my EPC rating, and I've had a heat pump survey done. I've already found out that my loft insulation is absolutely terrible, and I don't have cavity wall insulation. So I need to do those things, but I still have a heating system now that works. It just means that if I go and fix those issues, then I'm going to have a more efficient heating system.
Absolutely.
So, yeah.
And that is the, you know, I'm sorry if I'm going to say it again and again and again, but the beauty of a heat pump installation, and I should add, this should be true of any system installation, is you will have a system that's properly designed for your house. And not only will you have a system designed, you'll have all the figures. You'll get the heat loss calculations for each room, you know, your areas for improvement, you know, things you could do to make it better. So you will know what you can or can't do to make it operate as efficiently as possible. You don't need to go to the problems of the expense of insulating under your floors. I mean, you can do, but you don't need to. The heat pump will still achieve what it needs to achieve. And I'm guessing in many cases, suspended floors will still be carpeted or have rugs or have something over them. Which in and of itself, I mean, I know it's not much, but that will act as a buffer and an insulation buffer in and of itself. You know, if you've got suspended floorboards and nothing underneath them, you're gonna have a pretty drafty house, and that might be a problem. So, you know, suspended floorboards is not an issue. It can be overcome with heat pump design, and you might run your heat pump slightly differently than someone who has. But it's not a barrier to having a heat pump.
Perfect. Okay. I'll move on then to the next one. Humph, I'll come back to yours with what should the heat pump survey output look like, because I've got an example that I will send around to everyone afterwards. Again, I mean, actually, I'll bring it up now. Richard, you might have a response on it, but again, I think it probably depend on the company that comes. And how that output will look like, you know, how many pages, etc. So thank you. Never wants to miss being on camera. There you go.
Hi.
We need a cat. Where's the cat? Where's the dog? So is the question,
the dogs are out.
Am I looking at Karen's question? Is there an average cost?
Sorry, no, no. Let me just go back. So what should we expect a full heat loss assessment to look like once the installer has undertaken their survey? Like I said, for everyone, I'm happy to share the output of the one I had after the group. So, but if there's a minimum requirement, then.
Well, again, that all comes down to the MCS standards require certain things of a heat loss survey, and perhaps rather than go through them all, I mean, it's comprehensive. You'll have a map of your house, detailing the heat loss for the entire house. You will have, at the point that you get the full heat loss calculations, the heat loss survey done, you will get 5 or 6 pages of information. You have a map of your house, the heat loss calculations for each room, total annual energy consumption, predicted running costs. It's a comprehensive document that, if Kate's happy to share, I mean, you will see it's comprehensive. It's not, oh, you need a 14 kilowatt boiler, I've got one in my car. You know, it's 6 or 7 or 8 or 9 or 10 pages of detailed information on your home, on the heat pump that they would specify, you know, whether you need to change radiators, to what size. It's a comprehensive and you know, almost complicated document to read, because it's detailed. You know, it's not, yeah, you need it. It's not, you need a new boiler. Yeah, I've got one. I'll just whack it in for you. It's comprehensive and bespoke to your home. And it's a requirement of an MCS installation that you get that prior to agreeing anything with the installer.
Yeah. And then just following up on that, like you said, Richard, they will then give you a recommended make and model heat pump to your property, because it'll be assessed on your usage, your rooms, your heat loss, etc., and any recommendations that they think you'd need. I'll just follow that on with the other question, which is there an average cost for a heat loss survey? So for mine, it was free, and I have I did actually say to the company, do you mind me sharing your details with other residents, because I'm sure there'd be quite a high request. I think one of the issues we're having, Richard, is because we've got such a public issue that there's obviously a lot of companies that won't come near us because they effectively don't see it as them getting any business out of it. So then they're not doing it for free. Most of them are not doing it for free. I was surprised that I got one for free, and a few others have as well. But is there an average cost? You know, because I think there's a few people that are charging £300, £400, £500, £600. So what would you say? What would you say would be average?
I wouldn't. I mean, that's going to be down to the commercial interests of the companies involved. So I couldn't really comment on that, I'm afraid. That's and it will vary. But yeah, that's going to be down to the individual companies. I should point out, and again, trying to provide some reassurance that should you go down the British Gas route, British Gas, if they end up the heat pump route through British, well, let's take a few steps back. Let's first caveat this by saying this is one of the frustrations I'm sure you all have, because you have no idea who might be doing the heat pump installations. But assuming that it's British Gas as a project partner and as an MCS certified heat pump installer with their own heat pump division, let's assume that. If you go down the heat pump route through the trial, they would have to do the exact same things because they are MCS certified as well. So they would have to do a full heat loss calculation, a full survey, and provide you with all that same information as any other installer would, because they are MCS certified. And as a way of trying to again provide you some further reassurance, British Gas are getting into heat pumps in quite a big way. So, you know, MCS work quite closely with them. They've got a relatively new training facility that they're putting lots of people through. So they are going to have to step through all the same processes that any other MCS installer would, although I can fully understand why you might wish to get some independent assessments done as well.
Brilliant. And I think that answers your other question, Marge, which is will we get the comprehensive assessment as well from British Gas and Cadent? And for anyone that's not aware, it was discussed on the Facebook forum yesterday that this is something that they should be offering at the moment, and Justin was under the impression that this was they were offering for British Gas and the heat pump side to come and do the heat loss survey assessment, which hasn't been promoted, etc. So I have gone to Cadent yesterday to say I want my full heat loss survey. I've already had a third party company do it as well, so I want to now see what British Gas do. to see if, you know, what the similarities or the differences are. So again, you know, if everyone else wants to do something similar, because I think, you know, it's human instinct, isn't it, that you don't want to take the first offer that comes along. You want to have an array of choices to make sure that they're all fairly consistent. So, you know, especially with it being such a new technology to us all, you want to understand that, you know, whatever British Gas are recommending, is that because they're recommending some, and I know they are MCS registered, which you do keep saying, Richard, but, you know,
No, I understand.
there's a lot of unease and distrust about the whole scheme. So we're just trying to kind of,
Sure.
suppose, err on the side of caution of, you know, what's the minimum acceptance survey that they would give, and then, you know, if we've got a comparison, it always helps, doesn't it? So
Absolutely.
hopefully that's answered your other question, Marge, about the assessment. And I'll get back to yours in a minute, 'cause I think Terry's got his hand up. So go for it, Terry.
Yeah, it was just a bit of information. I was quoted £200 for a technical heat loss assessment today.
Okay.
That seems quite reasonable.
Mm.
Yeah. I'm going to have to leave in about 5 to 10 minutes, I'm afraid. So if
Yeah,
there's some last questions, anything I'm more than happy to do another one of these another time. But if there's any final questions, I'm more than happy to whiz through them now.
Yes, but basically, so when they design the system, do they tell you how it should be run and used? So yes. And is there anyone that's got any other urgent queries? Because like Richard said, he's got to jump off in a couple of minutes, as do I.
Can I just embellish a bit on that answer for Anne? When they design the system, they will suggest what the best system for your house. But again, as part of the process, after they've done, so they'll tell you, they'll give you the basics on how to run it, or what you can expect from the system when they've done the design for you. As part of the handover process, they will show you how to use the controls, how best to run it, how to set it up, etc., etc., etc. One thing with heat pumps, I don't know if any of you saw the BBC link about heat pump geeks who get heavily into their heat pump data. Yeah, well, I'm not one of them. But if you want to, you know, you can go all in. You can tinker with it endlessly. You can change minuscule little settings to see, oh, I've got, you know, 0.1 of a difference in COP by doing that. Or you can do what I do and what most people do with their current heating systems. You set it up how you want it and you leave it alone. And that's basically what I've done. I've got mine set on what they call weather compensation. And I just leave it to do that. I set the thermostat to 19 during the day, set it back to 17 at night. It just does whatever it does. But at the handover point, once they finish the installation, they will run through that with you as to how best to set it up. And then it's up to you how heavily involved you want to get with tinkering with the system.
Brilliant. Thank you, Richard.
Okay. Kate's momentarily disappeared. So if there's any other,
sorry, I just went
yeah.
off camera because my family's behind me. So rather than them making impromptu appearances, but I was just going to say, I think let's wrap it up there. So you're not late, Richard. But what we'll do is we've got this recorded. So we'll publish it on the Facebook site. I will publish the link as well as to how you can locate an MCS installer. We've got the microbore question that we'll take offline.
Yeah. And I'm just going to see if I can drop into the chat now.
Perfect.
I
And I'll go out to the
Facebook
Facebook group again if we need to set up another session. So
yeah. Okay, good. Yeah, well, I'm more than happy to do another one, and through the Facebook group or directly through Kate. If you've got any more questions, please feel free to ask me. If I can't answer them directly, I know someone who probably can. But just to reassure you that the heat pump option, it's a good option. I said, I think in the first meeting I came to, if you really want to make the best of a bad situation, if the trial goes ahead, if you really want to future-proof your heating, go for the heat pump.
yeah,
Thank you.
perfect. All right. Thanks everyone. Thanks for joining. Appreciate it's, you know, an evening and amazing. Richard, again, thank you for your time that you're
welcome.
you know, that you're giving to us for this. So
welcome.
yeah,
It's my pleasure.
perfect.
Thank
All
you
right.
very much.
All right.
Thank you guys. Close it
Thank
there
you
then.
all.
Thank you. Bye.
Thank you.
Bye.
Take care.
Thank
Thank you.
you.
Bye now.
Yeah.